A pleasant greetings to all. In this video, I am going to explain important MCQs in power system. Question number 1. The positive sequence current of a transmission line is A. Always 0, B. 1/3 of negative sequence current, C. 3 times of negative sequence current, D equal to negative sequence current. The transformer or a transmission line, the positive sequence current should be equal to negative sequence current for the transformer and the transmission line, because positive sequence impedance should be equal to negative sequence impedance. But in the three-phase generator, positive sequence impedance that is more than the negative sequence impedance. So the answer is equal to negative sequence current. Question 2. For an unbalanced fault with paths of zero sequence current, at the point of fault, the negative sequence voltage is maximum and zero sequence voltage is minimum. B. The negative sequence voltage is minimum and zero sequence voltage is maximum. C. The negative and zero sequence voltages are maximum. D. The negative and zero sequence voltages are minimum. At the point of fault, zero sequence current is negative and zero sequence voltage are maximum. Option C is correct. Next question 3. Zero sequence currents can flow from a line to transformer bank if the windings are in grounded star bar delta, delta bar star, C star bar grounded star, D delta and delta. Here, zero sequence current can flow from line to transformer bank. So this is the equivalent circuit. Here Q and this is P. The primary winding is grounded star and the secondary winding is delta. So the answer is option A. Next question 4. If the positive, negative and zero sequence reactance of the element of the power system are 0.3, 0.3 and 0.8 per unit respectively, then the element would be A synchronous generator, B synchronous motor, C static load and D transmission line. Option D, transmission line is the correct answer. In a transmission line, positive sequence reactance that is equal to negative sequence reactance, but the zero sequence reactance that is 2 to 4 times of positive sequence reactance. So the option D. Next question, question 5. Negative sequence reactance of the transformer is A equal to the positive sequence reactance, B larger than the positive sequence reactance, C smaller than the positive sequence reactance, D none of the above. The answer is A equal to the positive sequence reactance. Next question 6. Zero sequence currents flow in the transmission line when there is grounded path, then only zero sequence current is flowing. Here options are A double line to ground fault, B an over voltage in the line caused by charged loads, C line to line fault, D a fault across all three lines. But there should be a grounded path, then only the zero sequence current is flowing. Option A is correct. Question 7. The positive sequence current of an LL fault is 2 kV system is 1400 ampere. Corresponding current for the LG fault is 2200 ampere. The zero sequence impedance of the system. For a LL fault, the formula is IA1 equal to EA divided by Z1 plus Z2. EA is given, the fault current is given, and IA1 for this is LL fault, and for LG fault, IA1 equal to EA divided by Z1 plus Z2 plus Z0. So here also IA1 is given and the GA is given. Using this, I have to substitute the value and finally I get the answer D, 0.52750. Question 8. The positive, negative and zero sequence impedance of the solidly grounded system under steady state condition always follow the relation. Z0 is less than Z1 less than Z2. P Z1 greater than Z2 greater than Z0. C Z1 less than Z2 less than Z3. D Z0 greater than Z1 greater than Z2. Here Z1 is the positive sequence impedance, Z2 negative sequence impedance and Z0 is the zero sequence impedance. For solidly grounded system, zero sequence impedance will be minimum because in that current will flow in the circuit, but reverse in positive sequence case. So the answer is B. Z1 is greater than Z2, that is greater than Z0. Question 9. The most common type of fault is. The most common type of fault occurs is single phase to ground fault. Question 10. The maximum short circuit current occurs in the case of three-phase bolted fault, B. A double line to ground fault, C. A line to line fault, D. A single line to ground fault. The answer is A. A three-phase bolted fault. Next, question 11. For the fault at the terminals of synchronous generator, the fault current is maximum for a three-phase fault, B. Three-phase to ground fault, C. Line to ground fault, D. Line to line fault. The answer is line to ground fault is the correct answer. Question 12. For a given base voltage, the base volt amperes, the per unit impedance value of an element is X. What will be the per unit impedance value of the element when the voltage and volt ampere bases both are double? The formula is Z per unit nu equal to ZPU volt into MVA nu divided by MVA volt into kV volt divided by kV nu, the whole square. So ZPU volt is X. When the volt ampere bases both are double, so new base is double the old base. So MVA nu, that is 2 times MVA volt divided by MVA volt. Here kV volt 2 times kV volt, the whole square. So X into 2 into 1 by 4. The answer is 0.5x. So option A is the correct answer. Next, question number 13. The equipment has a per unit impedance of 0.9 per unit to a base of 20 MVA, 33 kV. The per unit impedance to a base of 50 MVA and 11 kV will be. Here, the new base given are 20 MVA. New base MVA is 50 MVA and new kV is 11. Directly have to substitute ZPU nu equal to 0.9 ZPU volt and new MVA 50, old MVA 30 and old kV 33, new kV 11, the whole square. So 3 square 9, 9 into 0.9, 8.1 into this is 5, 8.1 into 5 by 3. That value is 20.25. Option B is the correct answer. Next question 14. When a line to ground fault occurs, the current in the faulted phase is 100 ampere. The zero sequence current in this case, zero sequence current, that is IA0, that is equal to IA divided by 3. Okay, IA equal to 100. So 100 divided by 3, that is equal to 33.3 ampere. So the answer is option B. Next, question number 15. When a fault occurs in a high voltage transmission line, first the A. circuit breaker operates, then the relay. B. relay operates, then the circuit breaker. C. relay operates, then successively the isolator and the circuit breaker. D. isolator operates and successively the relay and the circuit breaker. The option B is the correct answer. When fault occurs in a high voltage transmission line, firstly relay occurs, when sense a fault and circuit breaker works which isolate the faulty part. So relay operates, then the circuit breaker. Option B is correct. Next, question number 16. In three-phase system, what is minimum number of relays used to detect phase-to-phase fault? A3, B1, C6 and D2. The answer is D. In a phase-to-phase fault detection, there are minimum 2 numbers of relays are required. 2 numbers, option D is the correct answer. Question 17. The protection from negative sequence current is provided for. Option A. Transformer. B. Transmission line. C. Motors. D. Generators. The answer is option D. Generators. Negative sequence current is provided for synchronous generator. Option D is correct. Next, question 18. The flex setting of negative sequence relay is 0.2 ampere. The current transformer ratio is 5:1. The minimum value of line-to-line fault current for the operation of relay. The answer is the minimum value is 0.2 into 5. That is 1 ampere is the correct answer. So option A is the correct answer. Question 19. The earth transformer is used to avoid the harmonics in the transformers, provide artificial neutral air. Question 19. The earth transformer is used to A. avoid the harmonics in the transformers, B. provide artificial neutral earthing where neutral point is not accessible, C. improve stability of the system, D. measures the voltage. To avoid harmonics, we cannot use extra transformers same as it for improve stability and measure of voltage. So, option B is the correct answer. Provide artificial neutral earthing where neutral point is not accessible. Next, question number 20. Thermal relays are used to protect. Question 20. Thermal relays are used for protection of motors against overcurrent owing to short circuits, B. heavy loads, C. earth fault, D. all of this. The answer is B. heavy loads. Thermal relays are used for protection only for low voltage AC and low voltage DC motor. Okay, it can measure overloading faults which are around 7 times to the full load current. It cannot sense the heavy current which are occur in short circuit and earth fault because its element will burn before it sense. So the answer is heavy loads is the correct answer. Thank you. Have a nice day.